Okay, so today I will discuss working of n-channel depletion type MOSFET. And yesterday we saw its structure. So its structure looks like this. Like there is a P substrate and its source and drain are of N plus type materials, and its channel is of N type materials, and there is an oxide layer, there is a metal layer, and above that there is gate terminal, and at the bottom we have body terminal, and this source terminal is considered as reference voltage, like voltage of that source terminal is considered to be reference voltage, so we consider it to be grounded. And since here we are not taking into consideration body effect, so body voltage also will be 0. So source voltage and body voltage is considered here to be 0. Okay, now let's first see what n-type material and p-type material looks like. I hope everyone knows about it, but still I am just making it clear that there is no confusion. So if it is n-type material and if it is p-type material, then we have here positive ion paired with electron, and there will be many such pairs, and in p-type we will have negative ion paired with hole, and there also will be so many pairs. So this is our n-type, this is our p-type. Here positive ions are immobile ions and electrons are our charge carriers, and here negative ions are immobile ions and holes are our charge carriers in p-type. Okay, now let us see first what do we mean by N plus. N plus means highly doped. We know that our n-type material is formed by doping the semiconductor, but here an extra thing is used, that is plus sign, and that plus indicates that it is highly doped, not just doped, it is highly doped. So why do we dope any semiconductor? We use doping for increasing the conductivity, that is for increasing the conduction. So if it is highly doped, it means it will have more conduction, more conductivity or more conduction. And conductance is inversely proportional to resistance. So if it is having more conduction, means it has less resistance. So N plus is highly doped material. Highly doped means more conduction, and more conduction will lead to less resistance. Now let us see about N, just N. It is lightly doped compared to N plus, and so it will have less conduction compared to N plus, and less conduction means more resistance because they are inversely proportional. So from these two things we can conclude that our channel will have more resistance, our source and drain will have less resistance, because our source and drain are made up of N plus material and our channel is made up of N type material. So we can write here that our channel is greater than our source and our drain. Okay, now let me review this. Yeah, now since our channel is greater than our source and our drain, here we will assume that our channel is twice of our drain and twice of our source. So assumption our channel equals to twice of our source, and which is also equal to twice of our drain. And one more thing, here we can see that our substrate is of p type and our source, channel and drain are of n type, n plus. So n plus n plus, and this is p type. So here we can imagine a diode. Diode is not literally present here, but we can imagine that diode is here. Because substrate is of p type and source, drain and channel are of n type. So here we are just imagining to be 4 diodes, but diodes are not literally present there. Okay. Now we will first draw the equivalent resistance for our source, our channel and our drain. And this is drain terminal, this is source terminal, and one more thing, here we are considering the working of n-channel depletion type MOSFET for condition 1. First let us see what is condition 1. So condition 1 is that VGS equals to 0 and VDS equals to positive. So that means our VG will be 0, because already we know that VS equals to 0. So VGS equals to 0 means VG equals to 0, and VDS equals to positive means drain terminal will have some positive voltage. So let's consider here our drain terminal is having plus 8 volt. Okay. And we know that our source voltage will be 0 volt. Now this resistance is our source, and these two resistance combined together will form our channel, because according to our assumption our channel equals to twice of our source and twice of our drain, and this is our drain. Now these 4 resistances are in series, and in series we have equal current, same current through all the resistances. So we are assuming here our channel to be twice of our source and twice of our drain, and we know that all will be having same current. So our voltage will also be something like this, like voltage of channel will be twice of voltage of source and twice of voltage of drain. So since here it is 8 volt, here we can say that it is 6 volt, it is 4 volt, it is 2 volt, and it is 0 already. So see, our drain is having 2 volt, that is 8 volt here, 6 volt here, and difference is 2 volt. So potential difference across the drain is 2 volt. Now across the channel, these two resistances combined together is forming the channel. So potential difference across the combination of these two resistances is 6 volt minus 2 volt, that is 4 volt, and potential difference across the source is 2 minus 0, that is 2 volt. So here we can see that V channel is equal to 2 of V source is equal to 2 of V of drain. Okay. Now let's draw these diodes here one by one. all these diodes will have here same voltage here X, let it be X. So all will have X, 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 X because all are connected to the same P substrate. So it will have X voltage. Now we can see that this diode will have the maximum reverse bias compared to other diodes, and this diode will have minimum reverse bias compared to other diodes. Now why we say so that it is maximum, it is minimum? Because first of all, let us see what is reverse bias. Already I know, everyone knows about it. Still, it is P side, it is N side. Okay, when P side is connected to negative voltage and N side is connected to positive voltage, we say that the diode is reverse biased. So here we can see that our negative, that is N side is connected to plus 8 volt. Here N side is connected to plus 6 volt. Here N side is connected to plus 4 volt, and here N side is connected to plus 2 volt. So we can see that the maximum difference is here 8 minus X. Here the difference is 6 minus X. Here the difference is 4 minus X. Here the difference is 2 minus X. So the maximum difference is in this diode. So we will say that it will have maximum reverse bias, and this will have the lowest difference. So it is said to be having minimum reverse bias. Okay. Now we know that reverse bias increases depletion region width. Okay, let me take another marker. Yeah, this one. Okay, so reverse bias increases depletion region width. We all know that. So if it is having maximum reverse bias, it will have maximum depletion region width, and if it is having minimum reverse bias, it will have minimum depletion region width. So we can say that moving from drain to source side, that is moving from drain to source, reverse bias is decreasing, and that's why depletion region will also decrease. Okay, so moving from this side to this side, this is having maximum reverse bias, and this diode will have less than this diode will have less than this, and this diode will have the minimum. So a similar pattern will be seen in the depletion region, because reverse bias is directly proportional to depletion region. Now let me remove all this. If I draw, this is channel side and this is drain side, so it is drain and it is channel side. It is N plus material. So here it will be having plus sign, plus sign, plus sign, plus sign. That is positive ion, not plus sign. Yeah, but I'm just saying because I'm drawing it. Okay. Here we will have negative ion. And why this negative ions are here? How it came? Like these negative ions are from P substrate. P substrate is of P-type material, obviously, and in P-type what do we have? We have negative ion paired with hole. So here we are having those negative ions. And in drain it is of N plus type material, so we will have positive ion with electrons. So here we will have positive ions. Now in channel, channel is of N type material, so in channel also we will have positive ions paired with electrons. Okay, so we will just draw here electrons, and that too I will denote it with dots. Like, let me draw this first. Here positive ion, positive ion, positive ion, positive ion, and positive ion. Now these positive ions are here because the electrons which were paired with these positive ions are sucked towards the drain, and they moved out of the drain. Now how they got sucked out from there? So we saw that the depletion region in the drain side will be the higher, okay, not higher, highest. Okay, so here we will have a strong electric field because of that depletion region. Because of that depletion region, our electric field will be here from positive ion to negative ion. Its direction will be, and this strong electric field will attract these electrons, and then it will move out from the drain. So there is electric field because of the depletion region, and this electric field attracts those electrons, and those electrons then move out from the drain. Okay, so if this electron moves out from the drain, then what will be left? Because in N-type material what we saw, what we have, a positive ion paired with electron. So if electron is removed or it moves out, then what will be left? Positive ion. So in place of this electron, what will be left? Positive ion. So when we increase VDS, the number of electrons moving out of the drain increases, and that's why our positive ions increase here in the channel. Positive ion, positive ion, positive ion. And again if we increase it, the VDS, again our number of positive ions will increase because more number of electrons will be moved out of the drain. Now, but after a certain VDS, we will see that the number of electrons moving out of the drain does not increase, it just gets saturated. Why? It gets saturated because after a certain VDS, channel gets so depleted. Let me write using this red pen. So depleted of electrons that even after having strong electric field, the current saturates. That means when we apply VDS, our current starts. When we apply VDS, there is some current. When we increase that value of VDS, our current gets increased. When we increase VDS even more, our current gets increased even more. But after a certain VDS, we will notice even after increasing VDS, we won't see any increase in the current, because then our current will get saturated. And what is the reason behind that? The reason behind that is this. After a certain VDS, channel gets so depleted of electron that even after having strong electric field, current gets saturated. That means there won't be much electrons in the channel. So if there won't be much electrons left in the channel, then what will this electric field attract? It won't be attracting more electrons, because there are more electrons are not present in the channel. How will electric field attract more electrons? So that's the reason why our current will get saturated after a certain VDS. Okay. So if we draw the curve for ID versus VDS, here ID is our drain current and VDS is that voltage, this one, we will see that up to some extent it will increase, but after certain VDS it will get saturated. So here and this VDS after which current won't increase. And in this process, our VGS is considered to be 0, as I have written it in the condition that VGS equals to 0. So this is our ID max here in this condition, because after this ID max value, our current won't be increased. Okay, so this is it for today, and we will study the next condition for N-channel depletion type MOSFET in next video. And for today it is it. Thank you.